Okay, so we want to combine these two logarithms into just one logarithm. That would make things simpler. We can't use this property yet, though. So if you have log of a divided by b, then that's the difference of the two numbers inside a logarithm. Okay, can't use that though because there's a 1/2 on the outside. So the way to fix that is to use the exponent property of logarithms. If you're multiplying by a 1/2, you can make that 1/2 become a power inside the argument of the logarithm. And now this is like our a, and this whole thing is like our b. So we can combine those. That's log of a divided by b. And remember, a 1/2 power, that's the same thing as a square root. So that's where that came from. Okay, so we made it simpler. We combined the two logarithms. And now I see two different ways of doing this. One way is to recognize that this is a common log, so that means it's a base 10. So you could put both sides on top of a power of 10. That keeps the equation balanced. So I stuck the entire left side on top of the exponent of 10, and the right side put 1 on top of 10 as an exponent. And the reason why I chose 10 is to make these cancel out because they're inverses of one another. Okay, and now we have an equation to solve for x. So if you're not sure how to solve this equation, anytime x is in the denominator, that could be your first goal. Multiply both sides by the entire denominator to make it cancel out. Okay, so it makes this cancel out, but we have to do it over here as well. So get x is 10 square root of x plus 4. And we're getting closer. We need to get x out of that square root. So since we have one term on the left side and one term on the right side, we can just square both sides. So x squared equals, make sure to square the 10 as well. That's 100 now, because 10 times 10. And then the square of a square root is just x plus 4. So there, we got x out of the square root. Still trying to get x by itself, and you might recognize now that this is quadratic, which means we're going to want to try to factor or rewrite it somehow. So I distributed that 100. I made that multiplied everything inside the parentheses. And then quadratics, we like to set them equal to 0. So I'm going to subtract that 100x and subtract that 400 from both sides. So to get x by itself, you could use the quadratic formula, or you could try to find two numbers that multiply to be negative 400 but add to be negative 100. So how about negative 200 and positive? No. I don't know. Can we factor this? I don't know. No, that's not going to work. Not quite. No, not quite. No, you can't factor this, I don't think. Check with the book. The book doesn't say. All right, whatever. We'll just use the quadratic formula. No problem. So it's negative b, so negative 100 means a positive 100, plus or minus the square root of b squared, so negative 100 squared is 10000, minus 4 times a times c, and then this is all being divided by 2a. Excuse me. And then we can simplify inside the square root. I've got that 10,000, and over here it's going to be added because a negative times a negative will make a positive. So add that to 10,000 and then take a square root. So the entire square root is 107.70, we'll say. So this square root is 107.70. That's all being divided by 2. And then you remember how to handle the plus or minus symbol. You do it once for plus, once for minus. So I got 103.9 when I did plus. And then we got 100 minus 107.7 divided by 2. And I got negative 3.85 for minus. Now with logarithms, you always just want to check to see if these answers still make sense. If I go back up here, one of these is out because as discussed before, you can't plug in a negative number into a logarithm. You can't raise 10 to a power to change it from positive 10 to negative something. So this one's out. This is the only correct solution.